So this is mathematics now. You are welcome. You are welcome. So I just want to get the live stream link out to the others who may not be able to come in, because I would not want to be distracted when we start the live stream. I would want to also concentrate to learn too. All right. The live stream. Yes. I want to also concentrate to learn too. Okay. So I want to share the mathematics space science presentation. Mathematics subjects. Mathematics is the mother of all subjects, whether we like it or not. But then I always say chemistry is the king. All others are subjects. Yeah, chemistry is the king. All others are subjects. Yeah. I want to also concentrate to learn. Okay.
Maybe mathematics is the key and chemistry is the dog.
You say?
I said, let's say mathematics is key and chemistry is a dog.
Mathematics. Okay. So in a bit.
Good morning, ma.
Good morning. You're welcome.
Morning. I just joined for mathematics. Thank you.
Okay. Right. So I've posted Zoom link.
Okay.
So you can copy the Zoom link, the YouTube live link to the platform, so that and post it on the WhatsApp and share, so that other teachers who were not enrolled in this particular training, they can get back to it if they are not in right now. Right, Miss Muninu Ola, you have the floor. You can share it.
Okay. Yes. Thank
Are you
you,
able to share your screen?
Of course. Yes, I am doing that. Please let me know when you can see my screen. Let me know when you can see my screen.
I can see your screen.
Thank you very much.
And you have to go to slideshow.
Yes. So, good morning, distinguished and noble colleagues. Welcome to the mathematics space science presentation. And the theme I will be discussing on today is analyzing space mission data. And the topic is understanding uncertainty. That is the topic. For this study, we have 4 objectives. The number 1 is to understand the importance of statistical analysis in space mission data. The number 2 is to learn to calculate and interpret measures of central tendency and variability. Number 3 is to analyze data from a space mission to understand uncertainty, while the number 4 is to visualize data using plots and charts. Come with me. We'll be starting with statistical analysis, as it is crucial in space mission data to understand uncertainty, as uncertainty can badly impact the success and decision making. Let's start with measures of central tendencies. That is mean, median, and mode. These measures of central tendency help us to understand the middle ground of our data. And after that, we will be looking at the measures of variability, which is the range, variance, and standard deviation. The range is the difference between highest and lowest value in a set of given data. The variance is the average of square differences from mean, while the standard deviation is square root of the variance. The measures of variability help us to show how it shows us the spread of data. It shows us how the data spreads. Now, let's apply this concept to real space mission data. This is a real space mission data from Mars Curiosity rover. This is from Mars Curiosity rover temperature. On the table, we have the solar Martian day. A solar Martian day is very similar to a day on Earth. A day on Earth is 24 hours, while a day on the solar Martian day is 24 hours, 37 minutes. So for the 1000 day, we have the average temperature for the day, which is minus 12.4 degrees Celsius. The highest temperature for the day is 10.3 degrees Celsius, and the lowest temperature for the day is minus 34.5 degrees Celsius. That is very cold. That is very cold. Just like the table has analyzed to us, I have taken the average temperature for each day as the class temperature. In mathematics, in statistics, we have ungrouped data and grouped data. So for this kind of data, we are treating it as group data. So taking the average temperature for each Martian day as the class temperature. So on this table, I have each of the classes and the class temperature representing each of those data. Going on, we want to use each of the data we have on this table to calculate the mean, median, mode, range, variance, and standard deviation. Here I have the mean calculation. The mean calculation is calculated as the addition of all data present. In this case, I'm using the class temperature, which is the average temperature for each class. So I have mean as sum of data divided by number of data. The mean for each of these data is calculated as minus 12.4, minus 12.1, minus 11.9, minus 11.7, minus 12.4, minus 11.3, divided by 6. The result of which gives us the mean temperature for the data given as minus 11.96 degrees Celsius for the set of Martian day that we have. The median of any data is calculated as the middle value or the average of the middle values of data when the data are arranged in ascending or descending order. It is very key that the data be arranged in ascending or descending order before you pick the middle value. In some cases, if the number of data, the total number of data is odd, then in that case, you'll be having just one value as the middle value, and that will serve as the median. But if the number of data, the total number of data is an even number, then you will end up having 2 digits as the middle value, like I have there. The total number of data I have is 6. So to get the middle value, I am having 2 digits at the middle, which are minus 12.1 and minus 11.9. We have to get the average of these 2 values for us to be able to compute the median of the data given. So we have the median as minus 12.1 minus 11.9 divided by 2, which gives minus 24 divided by 2, which is equals to minus 12 degrees Celsius. So for the set of data given, the median is minus 12 degrees Celsius. The mode in any group of data given is the highest occurring data. The highest occurring data. I want to take you quickly back to the table. Back to this table, the class temperatures. We can see minus 12.4 appearing twice, while every other average temperature appears just once. That makes minus 12.4 as the data with the highest frequency or the highest occurring data. So our mode for this set of data is minus 12.4 degrees Celsius. Let us try to interpret this data. One of the very important definition of statistics is that statistics collects data, it presents data, that is like on the table, we have presented them on the table. Then statistics also analyzes data. So presently I am analyzing the data. I have gotten my mean, my median, mode, and right now I want to calculate the range. After the analysis of the data, we have to interpret the data, and we will get there. So range. The range of any value is calculated as the difference between the highest value and the lowest value. On the previously seen table, we have the highest value as minus 11.3 and the lowest value as minus 12.4. I want to believe that there is no confusion about this. Positive values are different from negative values. So when you are looking at 11.3 alone, you may want to contest it, that no, 11.3 is lower than 12.4. But these are negative values. The more negative, the lower the number is. The less negative, the higher the number is. So I have minus 11.3 minus 12.4. The difference of which gives 1.1 degrees Celsius. 1.1 degrees Celsius. So let us look at the measures of variability further. The formula for standard deviation is on the screen. The formula for standard deviation and variance are similar. The only difference is that the standard deviation is the square root of the variance. So remove square root from this formula, then you have the formula for variance. So I will be calculating, I will be discussing variance, standard deviation, the formula further. I won't bore us with the calculation of this standard deviation, but I will want to explain each of the parameters this formula constitutes of. The S is the standard deviation. The sigma, we call this, let me pick my pointer. We call this, I don't know if you can see my laser pointer yet. This I think it's a Greek alphabet or something, or Roman. It is called sigma. And the meaning is the sum of. So we are looking at sigma x minus bar x all squared divided by n minus 1. The x is the individual raw score, which is the average score, the class temperature I chose. The bar s is the sample mean. This square means whatever you get from that table, you subtract each average square from you subtract the mean value from the average value. Then you square each of them. After the squaring of each of them, you find the total. That is the sigma x minus bar x all squared divided by n is the number of observations or the values in the data. In this case, our n is 6 minus 1. That is the formula. You have to remove 1 from it. You want to ask why? Science is that our forefathers have done the work. All these things are verifiable, but why bother your head with it? Our forefathers have done the work. So we should just read from their label. That is actually on a lighter mode. That is on the lighter mode. Let's see the next slide. I want to go to the next slide now. Let us visualize a sample space mission data. Visualizing data is very crucial. If time permits us, if this was a regular classroom situation, we would have learned to create plots and charts to help us better understand the space mission data. This I have on my screen is an already done work. You can see that it's a NASA activity. All those tables, the table given can be represented like this with bar charts. They can be represented with bar charts, with pie charts, with line graphs, scatter diagrams, and histogram, whatever graph that is related to statistics in mathematics. Just like I told you that statistics do not only collect data, we present the data. After presenting the data, we analyze it. And all this histogram and the charts we have help us to interpret the data. This is another form of bar chart where we have the average number of planets per star on the vertical scale, and on horizontal scale, we have the planet sizes. This is an already drawn bar graph, also bar chart graph. The data we discussed earlier can also be represented in this kind of situation, so that at a glance, we can see the highest occurring data, which is represented here with this brown bar. You can see the highest occurring data, which is the mode of that distribution. Let us see the next slide. Very important is the need to think critically about how uncertainty can affect the space mission. How uncertainty can affect space mission. We know that space mission is out of this world. And when the mission fails, a lot of things will be affected. Economically, money is wasted, lives are lost also. So I'll be highlighting some of the effects of uncertainty on space mission. The number one in it is data interpretation errors. Uncertainty in data can lead to misinterpretation, leading to incorrect conclusions and poor decision making. Uncertainty can also affect risk assessment inaccuracies. Uncertainty can also affect resource allocation. I am just highlighting the points. I don't know how much time I have left. If time permits, I can come back to explain each of these effects. You are trying to tell me something, Dr. Banker?
Yes, you have 8 minutes to go.
Okay, so I will just highlight.
And that 8 minutes is actually for your for taking questions. So you need to round up on your presentation.
Round it up now.
Yes.
Uncertainty can affect resource allocation mistakes, timeline delays, budget overrun, communication failure, system failure, crew safety risk, and mission objectives can fail. It can also affect lack of adaptability in space mission, in any space mission task. On a final note, I want to leave space for questions. Let me leave space for questions before I take my summary and the key takeaways from this class. Thank you. Questions, please. You are muted, ma'am.
Okay. All right. House, distinguished mathematicians and other fellows, do you have any questions? Do you have any questions? If you have, please raise your hand. If I can't see any hand, then we'll move on. She rounds up and then we go to the next subject. Yes, I'm seeing from the chat that it's well explained and it's well taken. In fact, I never saw mathematics in this light. You know, this is fantastic. Absolutely amazing.
Thank you so much, ma'am.
You can take the remaining time to finish off. So you have 6 minutes left.
Or maybe I should also ask a question. I believe that I have my team members in the as my audience. Can I have 1 or 2 advantage of each of these measures? Mean, median, mode, range, variance, or even standard deviation. Can we have can I have a contribution from the house? Anyone, please?
What's the advantages with respect to, you were talking about light years. I mean, the time difference in space and on Earth. I want you to, you know, revisit that. I was trying to
yes. The Martian day used here is the Solar Martian day on Mars. And 1 Martian day on Earth is about 24 hours, 37 minutes. Even on Earth, we only take an average of 24 hours for our day. I did a bit of geography. I love STEM education. I'm a STEM educator. I teach other subjects apart from mathematics in STEM. I'm a full STEM educator. Even for Earth is more than 24 hours. It's just on the average, just like mathematics says average, the closest, rounding it up to the closest whole number is the 24 hours. But if we have to look at the Solar Martian day on Mars, we can actually call it about 24.1 days. So if any estimator estimates using the 24 hours on Earth, that is what we call data deficiency. And the data deficiency can also affect the space mission success adversely.
Awesome. So now, mathematicians, go into your classrooms and raise those mathematicians who will help us to make data available, because this data is very important. We all know that
Yes, ma'am.
everything we practically do is driven by information, data, right?
Okay, ma. Okay,
Thank you
ma.
so
Okay,
much,
ma.
Okay,
Munino.
ma'am. You're correct, ma'am. You're correct,
Yes, ma'am.
ma'am.
Let's take
Okay.
our
Let me
picture.
You are
quickly
looking well.
conclude.
Okay,
Let me
she
quickly
wants to conclude. She
conclude.
still has 3
Yes,
minutes.
That
I
was
want
a great
to
presentation.
conclude my presentation. So I'm concluding with the key takeaways. The key takeaways from this presentation is that statistical analysis is crucial in space mission data. Measures of central tendency and variability, like we have seen, are also important. Data visualization representing with graphs are also very key. Uncertainty can affect decision making, and statistics, unlike most of us have thought previously, statistics have real world application, and it is directly involved in space sciences and space engineering. Very, very key. So, just like Dr. Banke has told us, we are going back into our classroom to impact our world positively, to impact our students. Maybe I, maybe you, maybe any of our students will one day be able to go into space so that we don't lose their lives and the investment of our dear nation, Nigeria, in such mission. Thank you very much for your time and attention.
Thank you, ma. God bless you.
Right.
God
This is
bless
Good
you, ma.
job.
very
Thank
fun.
you.
Thank
I'm
you,
going
ma.
to take a group picture. My favorite part. Yeah. So we want all our mathematicians. Yeah. I represent my Niger. Proudly Nigerian. Okay. Can we all turn on our cameras? We want beautiful faces. Look at Joseph Edegbe. He's so smiling. Oh man, that's positive energy. Love that.
Thank you, ma. Thank you, ma. Thank you, ma.
Mr. Tunde,
Thank you,
smile
ma.
now. Your face is looking too serious, sir.
Mathematics is the father of all nations.
We rule. We
Great
rule.
mathematician.
Great
Great
rule.
mathematician. Great mathematician.
Great
Okay. So can we see how turn on their cameras? Let me see the screen that has the most camera turned on. That's the one I'm going to use. Right. Okay. So at the count of 3, Moninola, you can also take pictures from your end too, right?
Okay.
Daniel, I want to snap picture. Come.
So let me
At the count of 3, I'm going to be
Come.
taking
Oh.
3, 2, 1, go. I'm going to take one more.
Leave my back. We are snapping now.
3, 2, 1. Gotcha. Gotcha.
Thank you so much, ma.
Thank you
Beautiful,
very
wonderful.
much. Thank
It's
you.
really
Thank you
amazing.
all. It was wonderful. We are going to practice this in class. No,
Thank you very much, ma.
thank you very much. Thank you very
So
much. God bless you.
awesome.
Yeah, thank you. It's over. Our presentation is over.
So
Our
up
practice.
next, we have physics.
I want to go out. We are through with us.
Bye, y'all. Bye, y'all.
Bye, ma. Thank you so much for the opportunity. We appreciate you, ma.
Bye-bye. Bye-bye.
Bye. That's my baby.
God bless you. Thank you for the opportunity, ma. Thank
God be the
you.
glory.
Thank you.
To
Thank you.
God
Hope you
be
can see me,
the
ma.
glory.
God bless you. Thank you for the opportunity, ma.
Thank you, ma.
Thank you,
Thank
ma.
you.
Thank you, ma.
Physics is
Thank
up
you, ma,
next.
for the opportunity.
Bye. Thank you. Bye bye.
Thank
Thank
you,
you.
ma. Thank you, ma.
Hello. Bye.
Thank you, ma, for the opportunity given to us. Really appreciate it, ma. Thank you, ma. Thank